Okay, now we're ready to talk. This is my test station. What I'm testing is the tender assembly with the DC motor and with the Next Gen S Smart Smoke control board. As you can see, smoke works. I'm running it off an AC transformer. I'm going through a voltmeter here on the DC after it goes through the rectification, and it's coming out of the reverse unit. I wanted to see what the voltage was coming out of the motor controller. So this is going into the motor. This is just an auxiliary, don't worry about it. And this is what's at the smoke, and you see it's sitting at 8.99 volts and lots of smoke. And there's a way to dial that down if you want. Created a little schematic. Here's the transformer getting AC. The AC goes into the rectifier. That's this big black thing right here. That converts the AC into DC, but it also has a path where the AC can go down and into the reverse unit, which it is designed to handle. It has its own built-in rectifier down here. So that's working the way it should. Then I have the DC coming out in a buck boost port, and that goes to the buck boost port, which is on the back side here. And the buck boost is a volt regulator, and you can adjust it. This one's adjusted to 9 volts, and this is telling us how it's doing, and it's at 8.92, although lights doesn't look like that. So the buck boost board sets that up, and that goes to the smart smoke system, which is right here, and these leads go to this meter so we can see what's going on. And of course you can see it's smoking now. There is a leak inside. That's what I use to put my heat probe to test. This is an R&D machine, okay? So that leak is actually for a test probe. And I don't have all the screws in because I take them off and on a lot. I put the stack on so you can see how it really works. A lot of hum in this particular gear set. It's an old chassis, and I might not have assembled it as nicely as I should have. I was in a hurry. I'm running a vintage DC motor, America Flyer, open frame, obviously. The magnet used to be this little black thing like that, and I've replaced it with 5 super magnets, so it's about 10 times as strong. I'm running at 8 volts, which is about 50% on the transformer, and we've still got 9.3 going to the smoke. Isn't that magic? So at lower speed, even lower, 5 volts, you still have 9 volts, 9.3, and still have good smoke. At high speed, it sticks to 9 volts. It does not increase, so you have good smoke. But as you can see, we're up to almost 13 volts, or 12.5 volts at full speed. Okay, so now this particular, all these bits are my mule, test mule, in-house. So now I'm going to change these parts out, and I'm going to put in a customer's set. I just built 3 of these and 3 of these for a customer, and I'm going to test his system to make sure it operates the same as mine. I may not videotape that whole thing, but I may videotape one of them so you can see how a customer system would work in this setup. Okay, so that's what we've got. This is a Frankentrain design PC board. Andy put it together. We had it printed. I stuffed it, and it's a design modeled after the Lionel 0103, but we've made some changes. We've tried to make some improvements in certain components, 1 for reliability and 2 for robustness, okay? So it's a little bit improved, but it's a fresh board, brand new, built like a week ago, okay? All new parts. Rectifier built in, little power distribution panel built in, buck boost board, a little warm, gives us our 9 volts, and the smart smoke is the temperature regulated heat for the smoke, so that you have good smoke at all speeds. Okay, gang, I'm going to shut her down, do some real testing for my customer, and then I'll get back to you and show you how his systems worked out. Later.